All right, because it took me like 10 minutes to draw this picture, but I was off for a second, so I could draw it for my third period class, and I don't really want to spend 10 minutes drawing it during this. I am going to pull up my video and show you this problem. But you probably can't hear me here. Will you tell me? Can you hear it all? Or would you rather me like just talk? Oh man. Buffering. Not what I'm looking for. What the heck? Okay, I'm out of control now. Hold on. I've lost it. Okay, how about this? So, if you do your homework, you saw this kind of problem. If you're not doing your homework, dude, wake the heck up and start doing your homework, okay? And if you're just copying my stuff, dude, that's gonna help you like for another week, 2 weeks, and then I'm gonna quit taking up homework. And if you're not doing it, you're just gonna get smoked. Don't do that to yourself, okay? Anyway, there was a problem in the book. It was one of the book problems from recently, I think. And I gave you this picture of a function, and then I said, if you can't read this, what's derivative of f of x times g of x when x is 5? Okay, so I said, what's the derivative of f of x times g of x when x is 5? Now, I know that if I were to say that and didn't have this picture, you would just start with the first d second plus second d first, right? And then instead of writing, like a lot of people make the mistake, and I've mentioned this either in a video or to you guys, a lot of people right here will do this. They'll go, oh yeah, now I just need to plug a 5 in, and then they write this. Why is this wrong? Now, it's not wrong to get your answer, but why is it wrong to write it like this? Because it's not the derivative. Are you with me? The derivative is that. What is this? The derivative of 5. And if I write that in an AP test, I have now just written a false statement. Because the derivative is the slope of the entire curve at any particular place. And I've just said that the slope of the entire curve at any particular place is the slope at 5. So what you need to do is say, okay, the derivative is equal to this. And then you would say, oh, the d dx of f of x dot g of x, remember the bar? Yes. When x is 5, that's what this is. Okay? Now, how do I go about finding that from this picture? So this is saying, where is the y value of f at 5? So you'd say, oh, the y value of f is the darker function right there, and I would go up, and it looks like about 3.5. And if that was a test question, it would probably be some whole number, and you'd probably have a grid. It'd be easier to tell that. So you'd say, oh, okay, so that part is 3.5. Pretend that's not there. So 3.5 for the first part. Now, what is that saying? So the slope of the g function when x is 5. So there's the g function. When x is 5, it looks like the slope is, and don't just eyeball it. I mean, look at the 2 points, 3, 4, and 6, 1, and find the slope, but you'd see it was -1. Are you all with me? And then you just plug a -1 in, and multiply those, and then you just continue this process. Are you with me? And that's how you find the derivative there. And what would happen at some point if I said, if I was asking you a derivative or whatever, and it was right there? Like, what would be the derivative right there? It's a corner, so it's not differentiable. So the derivative does not exist. So the whole thing just, so if any part of this didn't exist, then the whole thing would not exist. All right? Okay, so we good on that? All right. Then I will move on. Oh, and then if I had asked you for the composite function, this number 2, and I said, what is the derivative of that? But then I asked you, how about, well, you'll see it. How about, if that's the case, what's the derivative of h? See how much better it is when I've renamed this as h, then I can say the derivative of h at 2. Because this wasn't renamed as h, I had to say the derivative when x is 5. This I can say, oh, the derivative of h at 2. But I still need to find h prime of x first, right? So how would I do that? How do I find, first I need to find this. What do I have going on there? Chain, not a product, right? Product, is, I mean, I know it's just one little letter different, f of g of x, f of x, g of x. So f prime of the blah, then g prime of the blah, then the derivative of the blah, which is just 1. So now I can say, but don't say, oh, that equals, and then start plugging a 2 in and write it out to the side. Are you seeing why that's wrong to the AP reader? You guys listen, you guys have always been on this quest to get answers. And you've been the smart kid in the class that's probably 3rd grade in math or whatever. And you could just get your answer. And you wanted to skip the work and not copy the problem. I mean, I'm still hearing from my 10th graders, do we need to copy the problem down? I mean, when it's a one-step problem, it's not a big deal. But when it takes a page, my son sent me a picture of a problem he was doing in actuarial science. I would show you, it's on my phone, but it's awful. But it's like 27 lines of hard integral calculus that he's doing for this. I told him, I was like, the student has become the master. Like, it's brutal. I don't ever remember doing anything that ugly in his actuarial class. But the form is important, and the AP reader is giving you points for that form. So don't just say equals and then plug a 3 in because you immediately just made a bad statement. Go ahead and take that extra line and say, okay, now I'm going to find it out. So what would I do? And don't be afraid to write an extra step. What do I do first? Oh, I said it 2, not 3. So what do I do first? The g function at 2. So g at 2 is up here. Now that's going to be a little tricky because it looks like I'm rising 1, running 3. So at this point, I guess I'm, what, 3 2/3? Are you seeing that? Yeah. How would you figure that out on the test? Like, what if that happened to you in calculus? How did I know it was 3 2/3? Other than, I mean, what did I do? This is the kind of thing that AP will make you do, and they don't want you to eyeball it. I mean, I've got a similar triangle here, don't I? So I could say, all right, 3 is to 1 as 2 is to, I'm not sure. Could I do that? Yeah. So 3 is to 1 as 2 is to, I'm not sure. So call it x. 3x equals 2. X is 2/3. So I was 2/3 up right there. So 3 2/3. I mean, just say a little similar triangle situation. You could, I guess, find the equation of that line and say slope is 1/3 x plus 3. And say what happens when I plug a 2 in there? Y is 3 2/3. There's a lot of different ways you can do it, but make sure you get that value right. And then so since that's 3 2/3, now what am I doing?
The slope of that on the f.
So the slope of that. So the slope of the f at 3 2/3 is, what's the slope of that thing? Looks like a rise 1, run 2, rise 1, run 2. So the slope looks like about a half. And then the slope of g at 2, oh, I meant to do that. The slope of g of 2 is up here. So back to what? Wait. No, that's right. G of 2 is that. And now I want the slope of g at 2, which is 1/3. You all with me?
Yeah.
So 1/6. And again, if I make one of these, I won't just be knocking it out in the morning right before class starts. I would have anticipated what numbers are going to fall where and try to make it where it's nice little bit nicer whole number action going on than this. But AP's not afraid of making you think fractions, and the best way to think about it, it's usually a straight line. Just draw a triangle and a smaller triangle and figure out that missing value that you want. It's probably the easiest way to do it. All right, so I wanted to mention that because every year I have given that problem as a test. I just get massive amounts of misses, and it's probably because you didn't do your homework, but or if you did do it, you didn't ask about it. There's one person asked me. Any questions from anything we're doing at this point? I hope that confidence is real confidence. Anything whatsoever. Nothing, really? Don't know how to do every problem I've given you on this homework.
Yes.
Really? And that's great, it's true. Well, all right, I'm just going to randomly pick some stuff out then until you interrupt me and ask me a question. So I'm going to go to this. You do not have this. These are old AP questions. Actual for AP tests. These are, again, old ones. And I'm just going to throw some stuff out here like number 2. AP Calculus loves this stuff. Oh, they give you a piece of information and then they say what must be true 1, 2, 3. And you have to pick. And it could be 1, it could be 2, it could be 1 and 2, it could be 1 and 3, it could be 2 and 3. It's definitely not 1, 2, and 3. And you know this is old because now the AP test just has A, B, C, D. So instead of 5 choices, it's just 4. So what do you see there?
Definition of a derivative.
It kind of looks like they're saying the definition of a derivative of a what? Of a function f, where? At 2 is what?
5.
So the questions now are, is f continuous at 2?
Yes.
Tell me why.
Because the value of the limit exists, there is the limit of value.
But you can get an answer for a limit. I'm just going to build on what you just said. You can get an answer for a limit at a whole.
Yeah.
Why do you know that 1 is true? What did you say this meant again? It's the definition of a derivative. So this function has a derivative at 2. And if it has a derivative at 2, it's differentiable, right? And if it's differentiable, it's certainly continuous. So that knocks out both of those, right? And then this says what? The derivative of the function is continuous at 2. We even talked about that? That just sounds bizarre, right? I'm going 1 and 2. What about this? Number 3, you have a calculator in your hand. It is not for a pillow. Okay, I haven't really kidded with you about this. It is shocking to me at the end of the year. I'll give a calculator test, practice test, all right? And people will be holding their calculator right here in their hand. And I will ask them to take a derivative that's equal to 3 or whatever. This is maybe, we haven't really talked directly about this, but it's amazing how much time people spend manually calculating the derivative. Do you really want to manually calculate the derivative? If you don't have to. And on Wednesday, I showed you in that video how to use your calculator to help you, right? Now, what am I saying right here? You've got this weird function that I have no idea what it looks like. It says, for what value of x is the slope of the line tangent to this? What is the slope of the line tangent to that? The derivative. So I'm asking you, when does the derivative of x, what? Equal 3? Now, I don't know if you know this, but if I want to know where the derivative of that equals 3, the hard way to do that is to actually, and that's what it asked, right? Where's the derivative equal 3? Where's the slope of the line, tangent of the curve, equal 3? If I want to know that, do you know that if I ever want to know these two, how to solve an equation, and I don't maybe know how to do it manually by hand, do you know that you have two options? One is, you could just name this y or f1 of x or whatever. You could call it y. And then you could call this one y2. And I'm writing like this is what the Inspire uses for y's. The 84 just uses y1 and y2, right? If I want to know where this is equal to this, what would you do? Graph and find the intersection, right?
Yeah.
So that's one option. You can literally break this up and find out where these y values are equal, right? Because they're both equal to y. That'd be like the substitution method, right? So you could break it up and say, hey, where are these equal? Graph that, graph that. But even better, I think, and this is what I do all the time, I'm just going to take this, subtract it to the other side, okay? And I'm just going to graph this as a y, y1 or f1 of x. And I'm going to basically say, where does this graph's y values hit 0? So you just graph it and let your calculator do the work. And literally, I can type that in as a function. I don't have to manually do it. Like, look, I can go here. Okay, but let me type it in while I can still see it. So I'm going to type in, tell you what, I can see right there. Hold on. Let me hold this up. Okay, so if I have a calculator out, I'm going to type in ddx of that. Now, you know how when I told you to manually calculate the derivative, I told you to go through, if you had an Inspire, I told you to go through menu calculus. Remember that? But notice that when you're graphing, you can't go through menu calculus. They don't want you to do that, because if you do that, it gives you the x equals value. Are you with me? And you don't want to find the derivative out of value, you want to graph the whole function. Okay? So what you do here is instead of going menu calculus, because it's not an option, you go, see the little absolute value button by the book? If you click on that, and you go over here to right there, you'll see the derivative feature. And you can just hit enter on it, and notice the difference is it doesn't put that bar down, so it doesn't calculate the value at one spot. Because you don't want that, you want the whole derivative, the whole function. So if you do that, and then just put x, and then type that function in, x, so I type in 2e raised to the 4x squared, right? Take the derivative of that, and then come out of there and subtract 3. And when I graph this thing, menu, window, I'm just going to go a standard window. No. Derivative with respect to x of 2e to the 4x squared. Are y'all seeing this? So I'm just going to graph that thing, and all I got to do is find the zeros. All right? And I let it do its work. Otherwise, you start doing this manually. Okay, copy it down, multiply by 8x. Maybe if it's not a base E. And by the way, I always said it would be base E on a non-calculator problem, but on a calculator problem, they don't care. So if you accidentally forgot, like that was base 4, and you forgot the ln4 in there, you just missed it. And there's no work on a multiple choice. But now I can look at this, and I can see it crossing right there, right? See it crossing? So now I can just go back menu, analyze the graph, find the 0, do a little left bound action, do a little right bound action, and there it is at 0.167. And I've got my value, which rounds to 168. So these kinds of things you're going to see a lot of, but again, if it's a calculator problem, which I think your test is going to be most, if not all, no calculator, because we haven't spent a ton of time with this. But what I just did there, solving an equation that you otherwise might not be able to solve, man, I don't think you guys have the well, yeah, you do. No, you don't. If you'd have taken the derivative of this, 2e to the 4x squared times 8x. How in the world are you going to solve that? Even if you move the 3 over there, you can't factor it. I mean, you can clean this up a little bit. 16e to the 4x squared times x equals 3. Even if you did this, I mean, how do you even try to factor that to solve it? You don't have the algebra, nor do I. But we don't need it because we have a calculator that really works well for us. Let me show you some other stuff. What about, and again, interrupt me if you have a question. Just looking for different stuff.
Can you do a derivative when you have like 3 products? It's like something plus
Sure.
something plus something.
Yeah, I haven't mentioned that directly, but it's kind of a, I'm going to do a really simple one. But I'm not going to use x, just so you see the rule. If I want to take a derivative of a product, an ABC, or like an FGH, or whatever, any 3 things together, and you can't simplify it into 2 by multiplying something in. This order doesn't really matter, but take the derivative of one of them, copy the other 2 down. Then, take the derivative of a different one, copy the other 2 down. And then finally, take the derivative of the last one, copy the other 2 down. And then just add them together. And that's true no matter how many you have. And if you really think about it, when I only have 2 things, what is it? First d second plus second d first. It's just the product rule, right? But you can extend that product rule to anything by just taking the derivative of one of the letters, copying everything else down, and just moving your way through the letters. And the order is really irrelevant. And the order in the product rule is irrelevant too. I mean, if I want to go a prime b plus b prime a, I can do that. It just doesn't sound as pretty as first to second to second to first. And it won't match my keys as well, because that's how I think on my keys. What about something like this, number 5? This is something I'm willing to bet that most of you can take the derivative, but then you get here and you go, oh crap, what am I going to do now? Like, check it out. What would you do right here to take this derivative on number 5? F of x is that times that. Probably shouldn't have said that. Is product rule? Yeah, it's x root 2x minus 3. So the derivative is first d second. How do you take the derivative of the second?
2 times the root of the bottom.
Double it on the bottom. Derivative on the top, which would cancel that, plus second d first, and the d first is just 1. So here's what you have. You have x on the top over this plus this. Any ideas? Well, look at my denominators. They're all irrational denominators, so don't do that. Even though normally that wouldn't be a terrible idea, because that's what you've been trained to do. But when you look at this, you can see irrational, by the way, irrational denominators, nobody cares in calculus. It's like this big scam has been pulled on you. You've been making me rationalize for years. Why? I have no idea. Maybe because multiple choice questions are usually written that way, but not on the AP test.
Multiply by root 2x minus 3 on the top and bottom on the right.
So find a common denominator. So if I multiply the bottom by a root 2x minus 3, I get that. If I multiply the top by a root 2x minus 3, what do I get?
2x minus 3.
2x minus 3. So now I get
3x.
minus 3. Right? Now I'm not making you do a lot of this on this test, but random stuff that you might see. What about number 7? Big chain rule, right? What would you start with? So 2 what?
Sine x cubed.
And that takes care of the 2.
Negative sine times
Takes care of the cosine. So what is it? And by the way, I may do this on your test, which is not overly a big deal, I don't think, but what would you, which one of these is going to match? D? right? Because the 2, the negative 1, and the 3 give me negative 6, and then there's your sine x cubed, cosine x cubed. So make sure you can do stuff like that, simplify a little bit. We haven't talked about velocity and acceleration stuff, but we will. Great question right here for my test. And by the way, these are all AP tests. All AP questions. So I mean, you could go in the AP test right now and actually do a number of problems. I mean, if you did everything you knew how to do at this point, I'd be willing to bet you could get a, well, it's hard to say, but I bet you could get, probably scrounge up 15 to 20 points, which doesn't sound like a lot, but out of 112, you only need typically a 40 out of a 1 over 12 to make a 3. So you're halfway to a 3 if you knew everything that we've talked about so far. You know? And a 5 is like a 70 out of 112. Still lots of room for mistakes and still get a 5. What about this? Oh man, unit circle. Shouldn't have to know that. What are you going to do for the equation of a line tangent to the curve? What do you need? How do I find the point? Plug it in. What's cosine of 2 times pi over 4? Cosine of what? Pi over 2. What's the cosine of pi over 2? 0, because it's the x value. So the point is that comma 0. And that right there can eliminate those, right? And then what's your slope? So the derivative is what? Negative sine of 2x times 2. And you want the derivative at pi over 4. So what's negative 2 sine of 2 times that would be what? And the sine at pi over 2 is times the negative 2. So y minus nothing equals slope x minus x. Right?
Right.
Very common problem. You can totally miss it if you don't know the unit circle. And normally it's not pi over 2. It'll be like 2 pi over 3 or 5 pi over 6 or something. What about, normally we covered this stuff. I'm waiting. How about this? Oh no, we haven't done that. Never mind. Forgot about the tangent line approximation. Hey, what if I said find an equation of a line tangent to the curve, and I gave you that information right here? Are we okay? What did I just give you here? The slope is 5. What is that? Yeah, isn't that saying when the x value is 3, the y value at 3 is 2? So I got a point and a slope. We can find an equation of a line, right? This is a different question, but you're going to need to know that. Oh, look at that. Natural log of absolute value. We'll never need that rule. What do you do for definite for that? Ignore the absolute value. And if you ignore it, what do you get for a derivative?
2x.
So I'm ignoring that. So yeah, the derivative on the top, I usually say that junk on the bottom, the derivative of that on the top. Now, if you don't know your stuff, you're probably going to lean to this because you're thinking, well, I know there's got to be an absolute value in there, right? Y'all with me? Ooh, nice. Let f be the function given by this, absolute value of x. So I'm giving you what? F is the f is absolute value of x, so it is what kind of function? Speaking French, what? What's the square absolute value of x function?
V.
V for victory, right? Okay, so you got this v function.
That seemed too easy for that to be the answer.
Is that why? Okay. What's he doing? No conspiracy here. So if I've got this v function, what do I know about this v function right here? Is it continuous at x equals 0?
Yes.
Continuous? Does the value exist? Yes. Does the limit exist? Yes. Are they equal? Yes. It's continuous. It's just not differentiable. Right? Continuous just means there's no hole, no vertical axis. Doesn't it go right through there? That's continuity, right? But what's f of 0? 0. What's the limit of this function as x approaches 0? 0. Are they equal? Yeah, that's continuous. Is it differentiable? Why not? There's a corner, right? So that doesn't work. F has an absolute min. We're going to talk more about absolute mins and relative mins. But yes, it does have an absolute min at x equals 0. And what would that min be? 0, because it's the y value of the point. But we'll talk about the difference. Does it have a, well, again, we'll get into that in this next chapter. Does it have a relative min at 0?
Yeah.
Yes. And by the way, I think there's a video if you want to watch this weekend. Don't know that?
No.
Why not mention it? Hold on. Why do I feel like I've done this? I think it was the only way I could land before. Hold on. I have to sit now. Oh, no. Sorry. There's a video Monday, Tuesday. Have I mentioned that? Still did? Yes. Okay, then maybe I need to send out something. So, you'll see on Monday, you guys won't be here, so maybe I don't. Oh, no, I know what it is. There's a video, that's what I want to tell you. There's a video Wednesday, and I know they've gotten rid of the Google Meet. Y'all read that today?
Yes.
Okay?
Why do you? Oh, just because.
So happy about this. They took Helmer's in mine. I'm sure a lot of people recommended it. They used our wording.
Did any of the teachers like fight against it? Like, did anybody want it?
I never got anything done.
Like, I feel like every single one of my teachers thought it was.
Well, the thing that really stunk is you have rule followers. Like, I may not be a rule follower in life, but when I work for someone, I'm a rule follower. Like, I'm going to honor that even if they get stupid. So I'm holding meets, and Helmer's Friday asked his kids, all right, how many meets have your teachers made you come to? And he said the average was maybe 2.
Yeah.
So like
Really?
the people that don't give a crap are just abusing it, and the people
Every
that like
single-
are doing the most and really trying and drowning. So I think they just decided to make it office hours. So if y'all ever need something on like that Wednesday, you would just email me, text me. You got my number, right? So text me and just say, hey, can we do a Google Meet? And I'll just set it up and you just hop in. So that, which is going to be so much better for me. That'll give me the whole morning that I can work, as opposed to every 15 minutes popping one over and one person has a question maybe. And anyway, but there's a video for you guys to watch on Wednesday. All right, and I still may use that Wednesday, because if you guys want to do well on your AP test, you can't afford to miss 20-something days. If I just don't cover stuff for 20-something, if this continues like this, if I don't do that, we won't have a review. And most people's practice scores go from 2s to 5s, 3s to 5s. If we don't have 20 days, you're going to go from 2 to 2, 2 to 3. I mean, we need all those days to be able to practice and get better. So, anyway, what else I want to go over? Again, I'll stop at any point. There's some interesting ones in here. All right, what about this? Ooh, I like this book. This is a little wordy, but you got to get used to this wordiness. So tell me what you're reading. Let f be a function that is differentiable on the interval from 1 to 10. So you know that there's some function from 1 to 10 that's differentiable. And if it's differentiable, not only is it continuous, but you know there are not any what? That's true because it's continuous, but you also know that there aren't any corners, cusps, or weird goings-ons, right?
Yes.
Okay, so definitely continuous. Remember, continuous, continuous, continuous. Are there jumps with continuity? Can you just go from like here to here? No. So nice and smooth and continuous with no crazy business. Now, what am I giving you here? Points. So visualize that. Or do this. f of 2 is down here at -5, right? F of 5, call it, that's 5, is up there at +5. And then f of 9 is back down at -5. So this is all I know about the function and the fact that it's continuous. Now, if it's continuous, can you assume its behavior here?
Yeah, it's like, it curves.
So you think it's doing this?
Yes.
Okay, why isn't it doing this?
Well, it could be.
Oh, it could. And why isn't it doing this?
That's also a possibility.
Why isn't it doing this?
I mean, it could do that. I just know it's curvy.
Yeah.
Okay, it is curvy. Yes. But are y'all with me in that you cannot make assumptions about the actual behavior it takes to go from there to there and back, right? I mean, you can make some, which is good, but don't just assume it's like an upside down parabola. Okay? Now, what does it say? F has at least 2 zeros. That has to be true, because there's no way for me to get from here to here without jumping, like a literal jump, and skipping over it. At some point, I'm going to have to go at least once there, right? And at least once there. At least. But it could be like a zillion times, right? So is that true?
That is true.
Okay, so I know it's, oh, no, it's not that. All right, the graph of f has at least one horizontal tangent.
That is true. At the top.
Why not?
Because it could do this, like, it could go, wait.
It could go up past it. Like, yes.
So, yeah, it
Yeah,
does.
so either
No,
way,
it can't. Yes.
it'll still happen at some point.
Look, the only way it couldn't happen, you're going to learn theorems for this. The only way it couldn't have a horizontal tangent is if it didn't flatten out on the top. How is it going to get from here to there and not flatten out on the top? Well, the only thing I can think of is maybe this. But then it's not what?
Wait, could it go?
But it said it was differentiable, so it can't do that.
Could it go like up and then come down and then curve past?
That's what I was thinking.
Yeah.
It'll still have a line on top.
But to go, like, as it goes
So
up,
does that still count as a horizontal?
at some point it's got to flatten out to come back down, right?
No, what if it just,
Like in a V,
yeah,
that's a corner. Then it wouldn't be differentiable.
okay.
These are great things you're thinking. This is the
Because
kind of stuff
I was thinking it had to be differential at a point, but not at, that makes sense.
Yeah, what if it...
No, it says, look, the f is a function that's differential. That means everywhere.
Okay.
If the function's different, it's differentiable everywhere. So no funny business. No sharp turns, no cusps, no corners, none of that stuff. So if it's got to be smooth and curvy, at some point it's got to do what?
Have a horizontal.
It's got to flatten out and give you a horizontal tangent. You'll learn this is really Rolle's theorem in a couple of days. But so this, does it have at least one?
Yes.
Now, you saw if it was a sine curve cruising through there, it would have a whole bunch of horizontal tangents, wouldn't it? Up, bottom, top. So definitely true. Now, what does this say? For some value of c in between 2 and 5. Now, do you know what they mean when they're saying, what are they talking about? For some what? X value. Yes. So for some x value of c, let me go ahead and put these back. Between 2 and 5. So there's your 2, and there's your 5. So they're saying there is some value in between there, right? Where what? Where the y at that value is 3. Now, what's y equals 3?
Anything.
No, what is y equals 3? A what? What kind of straight line? All lines are straight.
Vertical.
You meant horizontal, yeah.
Horizontal.
It's a horizontal line. Y equals 3 means a horizontal line. So here's what they're saying. They're saying, in between 2 and 5, is there an x value where the y that goes with it would be 3? Yeah, how do you know that?
Because it's going to pass it.
Because it has to connect smoothly, right? Can't hop over it, right? So if it's got to connect between 2 and 5, it's going to have to go through 3. That's actually the intermediate value theorem. In this one problem, you hit the mean value theorem, Rolle's theorem, and intermediate value theorem all together. But you didn't even know those theorems, and you could logically think through it if you understood differentiable. Right? So if all three work, what about, ooh, check this out. Let f and g be differentiable functions with the following properties. Okay, so you have these functions. What is this saying? Speak loudly. What do you have? What does that say? The y values of the g function,
Agreed.
so they're positive.
Yes.
So where does the g function exist? Above the x-axis. All right, so you know the g function is above the x-axis for every x on its entire domain. That's all you're supposed to get out of that. Y'all seeing that?
Yes.
After a while, you'll get used to this kind of language and it won't bother you. If you're already used to it, awesome. What does this say?
The y value has 0 is 1.
On the f function. So here's what you got. This is all I have from this. On the f function, I know that it's 0, I cross 1. But I don't know what the function's doing, do I? I just know that at 0, it's up 1. So that's all I know about f from this, except I do know they're differentiable. So if they're differentiable, I know there's no funny corners, cusp, whatever, it's cruising along. Right? And I do know the g function is positive, so I know that it's above somewhere up here. All right? Okay, now, it says h of x is the product of f and g. So whatever h is, whatever f is, whatever g is, if I multiply them together, hey, yeah, sure, yeah. Keyboard to see Mr. Butler. Council there. After class. So, all right, so if that is the product of those, which I don't have any idea what that's looking like, I don't even know what f and g looks like, but I'm just going to roll with it. It says the derivative of h is the product of f and g prime. What? Now wait a minute. I thought the derivative of h would have been first d second plus second d first, right?
Yeah.
Well, what does that mean then? That it means this must have gone away somehow, right? Now, what does that mean?
The derivative of the f.
Either the g function is 0 or the derivative of f is 0. So what does this say? What's your function then?
Not that.
Blinking a little longer. Just like, hold on. Oh! Sorry. Can that be 0? Why not? Because it's always positive. So if it's always positive, what does that mean? That's 0. This can't be 0 because it's positive. That means that's 0. And wait, if the derivative of f at every x value is 0, and the point at 0 is 1, well, what do you know about f then? I now know f of x. If what line or what function has a slope of 0 everywhere but crosses there? Y equals 1. Yeah. A little dirty, huh? Yeah. AP loves to do this stuff to you. And listen, that question, if you go look up the stats on it, like, maybe I have it. Hold on, that's number, sometimes I have this stuff. Page 19. No, I don't on this one. Sometimes I'll have the actual information about how many people got it right. There are problems where you go, percentage of people got it right, 12. I'm like, it's multiple choice. Like a squirrel would have gotten it right 20% of the time. Like, that's how hard it was. It was so hard it actually made people do things that were even, like it led people in a false direction. And I don't know that this is one like that, the one we just looked at, but it's definitely something that's a little tricky. Because if you don't make that connection, which let's be honest, I mean, I've seen this problem a dozen times and I've forgotten, like, oh yeah, it can't be 0. The other one must be. All right, well, I'll post this video, and then if you want to look at the other video, there were questions asked. Some good, some pretty common, and it's a lot of videos, but you're welcome to check them out. And good luck on your test.